Hello everyone, I am Lasya and today I am here to present about the topic matrix chain multiplication in detail. So when we give input as n matrices such as A1, A2 so on up to An of dimensions P1 into P2, P2 into P3 and so on such that Pn into Pn plus 1. Here the goal is to compute the matrix product A1, A2, A3 so on to n matrices. The problem is in order to multiply this n matrices, we have to take minimum number of computations to derive the product. So let us consider a small example. Considering A1 of dimension 5 into 4, A2 matrix of dimension 4 into 6, A3 matrix of dimension 6 into 2. Now we have three matrices. So it can be solved into two different ways, that is A1 A2 whole of A3, A1 into whole of A2 and A3. In first case we get 180 as a optimal solution, and in second case we get 88 as an optimal solution. As in second case we get less computation, 8 we are considering second case 88 as the optimal solution. So what is the methodology used in this case? For Mij of matrix where Mii is equal to 0, we use the formula Mij is equal to minimum of Aik plus Aik plus 1 into j plus Pi into Pk plus 1 Pj plus 1, where P is the dimension of the matrix and Ai is the A1, A2, A3 are the matrices. And here the condition is I should be less than or equal to k and k should be less than or equal to j minus 1. By using this formula, we split the matrices A1 to AK. That means AI to AJ, we are splitting it as AI to AK as one part and AK plus 1 to AJ as another part. So we'll more deeply discuss by solving some example. Here they have given four matrices, that is A1, A2, A3 and A4, where dimensions are 2 into 3, 3 into 4, 4 into 5 and 5 into 3. Similarly, we consider A1 is equal to A2 into 3, A2 is equal to A3 into 4, A3 is equal to A4 into 5 and A4 is equal to A5 into 3. On considering the previous formula, we get Mij, we substitute I is equal to 1 and j is equal to 2. Minimum of A11 plus A22 plus P1, P2, P3. We obtain, since A11 and A22 are zeros, because Mii is equal to 0. They both are considered to be zeros. And substituting P1, P2, P3 values from the above, such as P1 is equal to 2, P2 is equal to 3 and P3 is equal to 4. We obtain the final solution for M12 is 24. Similarly, for M23, we take A22, A33 plus P2, P3, P4. P2, P3, P4 values are taken from the above. Then we get optimal solution for M23 is 60. For M34, we can take A33, A44, P3, P4, P5. Hence, we obtain 60 as a solution. For A13, similarly, we take A11, A33, P1, P2, P3, and we finally obtain 84 as a solution. In this case, M24, we consider two such matrices, two pairs of, that is A22, A34, P2, P3, P5 as one set and A23, A44, P2, P5, P4 as another set. Considering minimum of 96 and 105, as the minimum is 96, we decide 96 as the optimal solution for M24. For M14 similarly, we take three such matrices, that is A11, A24, P1, P2, P5, and A12, A34, P1, P3, P5, and third matrix A13, A44 plus P1, P4, P5. On considering all these matrices, we find minimum as 108. Hence, A1, A2, A3, A4 is an optimal solution with total number of multiplications, that is 108. Thank you.